Morning, guys. Welcome back to Sample Survey Methods. Today, I'd like to continue on Chapter 6 on the last sampling scheme that we would like to talk about in this course. If you remember, previously we talked about the different sampling scheme, including the simple random sampling, stratified random sampling, and cluster and systematic sampling. So the objective, again, to record the objective of sample survey design is to obtain some of the information about the population that we can describe about the population. And then we select samples from the population to do the calculations. So within our simple random sampling, let's say if we have the population list, we have the frame, we randomly choose some of the elements or some of the individual from the population and do my calculation to estimate the population. And no matter whether the population is randomly distributed or they have ordered, we would have the same result at a certain cost. Whereas for the stratified random sampling, that we have some information about the population itself, that we can carefully divide the population into different strata, so that we can, when we do the survey from each of the stratum, that we know that within the stratum, the characteristics of the variables that we're interested in are more, they are more similar within the stratum. So we said that they are homogeneous within the stratum, whereas between the strata, they are heterogeneous. They're quite different. And in stratified random sampling, one very special case is that we actually survey or we collect the data for every stratum. So we actually go into each of the strata and to collect the data. Within the stratum, we randomly choose some elements, some individuals. Okay, and systematic sampling would be like we have the population, no matter we have the finite population case or we have our indefinite population case, we choose the sample in a systematic way. So every case item, and then we choose the sample and collect the data from the individual in this systematic way. And then we also mentioned that systematic sampling is a special case of the cluster sampling. We'll look into that later on. So what happened to cluster sampling? Imagine that from the population that you have on hand, we do not have enough resources or budget or time to go into each of the groups, or we divide the population into different cluster, and we do not have sufficient time to go into each cluster or each group to collect the data. Then we simply say that, okay, we randomly choose a few clusters, and then we study each of the cluster in full. Whereas in stratified random sampling, we study every strata, and then we randomly choose some element within the stratum. Okay, so we can see the difference between cluster sampling and stratified random sampling. Cluster sampling, again, we divide the population into different clusters. We just randomly choose some of the clusters from the population, and then we study every individual within the clusters, collect the data. Okay, so another important characteristics for the cluster sampling is that we want that within the cluster, we want each of the elements, their characteristics would be quite different. So they are heterogeneous within the cluster, whereas between different clusters, they're quite similar. So that's why we can simply choose a few of the sample of the clusters and then to represent the entire population, because within the cluster, we already take all of the variances into account. Okay, so cluster sampling. All right, so let's say we have a population, then we can easily divide them into our clusters, and then we look into some of the elements within them. So examples of cluster sampling would be like the cluster for a household would be a cluster of individuals. Cluster of city blocks, we have cluster of city blocks that we want to obtain the data, and then within the city block, the elements would be household. or we would like to divide the school boards of all the schools into cluster of schools, and then each of the element within the school will be the students. So again, like we only want to sample a few schools because we think that in the school itself is already contain most of the data we need to know about the students. Whereas different schools, they're quite similar, so we would like to choose a few schools as our cluster sampling. Okay. Our other example, like the cluster would be the factories, and then within the cluster, each of the elements would be the workers. Or the polling station, as the cluster, each of the voters would be the elements within the cluster. Hospitals, different hospital as one cluster, and then the patients within the hospital would be treated as the elements. Trees would be a cluster of trees, and then we simply select some of all of the fruits of some of the trees from the entire farm to be our sample. So cluster sampling will be very effective design if that we don't have the full listing of all of the elements within the population, but we can easily divide the population into clusters, and then we think that, okay, we can simply collect a few of this cluster and look into this selected clusters of each of the elements. For example, if I go back to this trees and fruits example, if I have a fruit farm, and then I have lots of trees, and then I know that within each of the trees, they grow some apples, or so they grow some oranges. Okay, so we decided we look into each of the tree as a cluster. So we think that we have 1,000 trees or 2,000 orange trees in the farm. We can just think of, we randomly choose a certain number of trees as our sample. So we just treat each of the tree as a cluster of fruits to collect the data. Okay. If we don't have the full frame, we don't actually have the list of how many oranges on my list, but I could easily see that trees that contains cluster of fruits, cluster of oranges. Secondly, the cost of obtaining observation increases. So if I have separate the population into different cluster, so after I randomly choose some of the cluster to be sampled, that I just send people to go into this particular district or this particular cluster to collect the data. And that is relatively easier than to collect all the data from each of the stratum. Types of cluster sampling. So when up to this point, we think that would be one stage cluster sampling. Like I said, we have a population, we divide that into different cluster, we divide them into different cluster. If we decided just choose some of the clusters within to be included in my samples, so that would be one stage cluster sampling, because each of the cluster selected would be studied in full. We collect each of the oranges data within the tree. Two-stage sampling would be each cluster is further divided into several sub-clusters. So let's say if the first stage, we select a few trees to be included in my sample, and then within the trees, we did not look into each of the oranges. We have a second stage of randomly choosing some of these secondary units. We can do that using a simple random sampling, or we can further stratify them, right? So two-stage sampling would be a combination of first cluster, and then the second stage depends on using a simple random sampling or a systematic sampling to choose the second stage. Okay, so we want to compare the cluster sampling with stratified random sampling. First of all, like we mentioned earlier, very importantly, elements within the cluster should be heterogeneous, whereas the elements within a stratum could be homogeneous. right? So we want that within the cluster, we want to capture most of the differences. So let's say a household would be a very good example of a cluster, because household would consider having quite some of the differences between the individuals within a household. For example, like the age, if I'm interested in the average age of the household or of the population, then I would go for a cluster sampling, because within the cluster, within the household that I divide the population into, they captures the differences of the age group within the household, because we might have the grandparents, the parents, and the kids. So we can see the age is actually varies. But looking at different household in a certain estate, they would have similar structure of the family type. So again, the 3 generation or the 2 generations, etc. So looking at the age, then we can separate the population into households or into cluster sampling. Whereas for stratified random sampling, that we want within the stratum itself, they are more homogeneous. So let's say if I'm looking at the average income, a very good example that I always mention about is if I'm interested to look at the average income, then within the household or within, I divide the population into different districts. And then within the district, the household income would be more or less similar, or the affordability of the people living in the same district would be more similar. So they are more homogeneous within the stratum, whereas in different districts, then comparing Wan Chai and to the Sha Tin or Wan Chai to Kuntong, different districts, then the average income would be quite different. So between strata, they are heterogeneous. That's the total opposite for the cluster sampling. Okay, so in stratified random sampling among strata, we prefer them to be more heterogeneous. We talk about that. In cluster sampling, the sampling unit is a cluster in stage 1. So we have the population, we divide them into different groups. So stage 1 is to look at the entire group. So it would be the cluster. So the unit of inquiry would be the cluster itself, like the household itself. Whereas in stratified random sampling, the sampling units as well as the units of inquiry would be each individual. Okay, so that would be taken randomly within each of the stratum. In cluster sampling, cluster in the population are usually naturally exist. So we can, if we have the population, if we don't have the frame of listing, then we can easily divide them into clusters, like city blocks from the map. Whereas for the stratified random sampling, we need to obtain some of the information or from the previous census that we know that we can easily divide the population into strata, so that we know that within the stratum, some of the characteristics that they are more similar to each other. So let's look at this example. A sociologist wants to estimate the average income per adult in a certain small city. There's no list of residents is available. How can we conduct a survey? Like I said, if we don't have the list, then we can't randomly select them, or we can't divide them nicely into different strata because we don't know the characteristics within the group. Then we can either do a systematic sampling or a cluster sampling. So if we look at the map, we can see that we can easily divide the map into some rectangular blocks and some of the industrial areas and 3 parks. So we decided to have the population divided into clusters, and one cluster would be all the city blocks, and some of the industrial areas would be another cluster, and then the parks would be another cluster. So we can now, if we divide the map into some of the city blocks and some of the area, so we count there altogether 415 of the clusters, then we randomly choose some of the cluster to be studied. So if we are going for one-stage cluster sampling, then we choose, let's say, 25 clusters, then we just mark that cluster or from the map, and then we go into each of the cluster and study them in full.